Hello, you're here with data science teacher Brandon, and we're going to go over and we're going to discuss using the Hugging Faces library for sequence classification. Okay, so to get this to work, we're going to use the data sets from Hugging Faces and the transformer libraries, which is kind of the principal library from Hugging Faces. Okay, so Hugging Faces in the library, it's the name of the company. Data sets and transformers are what we'll use to implement this today. Okay, and importing here our standard data science libraries, we have our standard data science libraries here, TensorFlow included. And then for each for each model that we implemented today, we're going to import the tokenizer, the for sequence classifier, and the config file. Okay, so they each require their own tokenizer. They have each have little certain quirks that we'll go through today, and then the Roberta for sequence classifiers. This is for classification problems in sequences of words, and then config file if you wanted to change some of the options. Okay, or this allows you to set the hyperparameters of the model. Looking at all of these, we're doing Roberta, Electra, and just notice that for the tokenizer, it's the same, but for TF, we have to say TF Roberta, TF Electra, TF XL, TF Deberta, RoFormer. For each one of the different versions, we need to use the TensorFlow version of the model, but we just include the standard tokenizer and config file. Okay, datasets to load a dataset today, and we're going to use the TensorFlow.keras.callbacks learning rate scheduler to implement. Well, I think to hopefully make our models work a little bit better. Okay, so importing an emotion dataset from this is from the Hugging Faces I guess Hugging Faces hub that you can import this emotion dataset. And so there are, in this dataset, there are 6 different classes today. So here what we're doing is we're going to go import the dataset we're loading it from the load dataset from the dataset library. And then we're going to go datasets. Okay. And then we're going to, if we just take a look at it, you can see here the first 10 rows, text, and then the text, and then including the label that it was labeled as. Okay. So train here, just looking at it, putting into a data frame, putting the text and the label into a data frame. So we can play around with it, make it a little bit easier to work with today. And then validation, looking at it as well. Okay, so I think a good idea is to understand the max lengths of each one of these. What I did was a nice little, I guess, data frame in the end, really, of this, plotting the different labels right here, 1, 2, 3, and we can see the different lengths of each one of those. And just get a sense, and so we can get a sense here of the length of the different classes to notice if we need to maybe truncate or where we would truncate by decrementing certain classes versus others, but they seem pretty equally dispersed out, although you can see 4, 5, notice that 1 and 0 have more of the longer lengths, but I think something like 50 today would work good. Okay. So to set the decay steps that we'll use in the learning rate scheduler. So here we're just going to get 32 batch size, 10 epochs, math.ceiling or seal for ceiling divided by the batch size. So training examples divided by batch size, just rounding it up. And then total number of trig examples divided by batch size times the epochs. And so then we get our decay steps that we'll use kind of for each one of the models today. So the config file here. So going with Roberta first today, looking at the Roberta config, this is where we can set the num labels. You can set different things. Here's all the different options you can see if you wanted to play around with this, other things that you can play with today, and just getting a custom config file. Now, custom config is how really the config file is how you're going to set the hyperparameters in your transformer model. Okay. So this next is I'm going to go TF Roberta for sequence classification from pre-trained Roberta base config file, ignore mismatch to size. This is one thing I had to do for this data set to work, or just really truthfully to import this model. And so it all has, every model has its own little quirks is what I found is a good kind of overriding thing for the transformer libraries. They're all a little bit different. They're all the same, but a little bit different. Okay, so here initiating the model, making a learning rate scheduler. So TF, Keras, optimizer, schedule, exponential decay, initial learning rates 5 E5 decay steps, and then decay rate 0.9. Okay, so I'm just going to give that to the learning rate in the optimizer that I have down here. We're going to do sparse categorical cross entropy, and really important that we do this from logits. This is the way that it was designed to train, so we need to make sure that we put this here as it's false by default. So a really important step that we need to do when we're using TensorFlow. and import that. So then when we import it, we can see here if we want to look at the layers. So you see if you go for layer in model.layers, we have Roberta and classifier, and then just looking, are they trainable? They're all trainable. A good idea, and you'll see examples at the end. Generally, you probably just want to train the head, and it actually worked out the best, I think, in lots of situations, just to train the head. Okay. So here what we have is false and then trainable. Okay. So we're just going to set, so we have only the only the first layer then would be set to false, and the last layer would be trainable. Okay, so when we train it, or you can train it all, whatever you prefer to do. Roberta tokenizer from pre-trained, and then Roberta base. Okay, so this is again, just the key here is that you're using the same name, Roberta base, Roberta base. Okay. Making my essential data, the tokenizer is going to make the data right here. So what we're going to do is make our our sequences in integers from text. So here we're going to do the toList, get the text, toList, padding equals true, truncate equals true, return TensorFlow TensorFlow tensors, and not PyTorch tensors, and then max length here 50. So we're doing the same thing for the validation data. And then from that, what I'm going to do, just looking at it right here, I'm going to make a dictionary of the input IDs and the detection mask, just to kind of reduce the amount, and so that we can just give then this dictionary right to our model when we're training it, because these are the ones that it's going to pull out, the IDs and the attention mask. Okay. So fit this, and a really important thing to get this to train faster is to do the with tf.device device GPU. So you might not have noticed this right when I first did this. At the very bottom, I had this tf config list physical dices GPU, got the name GPU 0, right? Because I'm using a GPU. And so this is going to give me the ability, it's going to make it so much faster. Not just activating because you can say your runtime have the GPU, but actually using it is different, right? So you have to say with the device, with the GPUs, train my model. Okay, so the dictionary, giving my train labels, and the validation dictionary for the X values, and then the Y value is the label. Okay, then epochs, I have 10 epochs here. Going through, plotting the training history, the predictions, everything works the same as the TensorFlow model now. Okay, so there's nothing really super different. We're also going to do the argmax to get the position of the position of the highest prediction in that row of all the classes, and then that will give us the final prediction really value. So then we can put this into a confusion matrix and look at this value right here. So look at the confusion matrix. You can see that Roberta, it did okay, made some mistakes on some values. It did much better where we had more data here in the 0 and 1. Okay, and it kind of overfit a little bit to this one. Looking at electric here, Electra next. So same thing. I found that the config file didn't actually work the best. It was actually best to change the num labels, set the number of labels in our classification problem right inside the model here. Okay, doing the same thing, the exponential decay here, fitting or compiling the model with sparse categorical cross entropy from logits, learning rate schedule here, and going through this. The same thing here, I'm training it, so making only the first layer, the transformer, not training that, just the head classifier. Okay, and then same thing for the Electra tokenizer, importing the same from the same model here, doing this as well. Tokenizer and returning tensors. So in the tokenizer here, we're returning tensors, the tokenizer that we just imported above from pre-trained Electra tokenizer, length 50, padding true, truncation true, and we're returning TensorFlow tensors. So then putting it into a dictionary like we did before of just the input IDs and attention mask, and then the labels right here from that dictionary as well. And then with tf.device GPU here. You can see here, truly predicted really well. I found the Electra was probably one of my favorite ones after this. You can see really good predictions, 93% from only training the class. I found for the XLNet as well, it was best to use the num labels right inside of the initiation, right in front of the pre-trained argument right here, but you're giving it the XLNet base case right here. And if you wanted to change more options though, you could use the custom config to change all the different options that are available with XLNet. Same thing here, doing the exponential decay, then again sparse categorical cross entropy from logits, atom, learning rate equals learning rate schedule. Okay. Then doing the same thing here, only going to train, not training the first one, going to train the last two, the sequence summary and the logits. Okay. And then here, so we're going to train the last two, the layers, just not training the transformer in this one, just like we've always done. For the tokenizer, we had to do something special for the TFXLNet. We had to import the sentence piece and then, or install it and then import as SPM. Just to get it, you had to restart it after you did this to get this to import properly. But just to know, one little different thing there, but I imported that. Okay. Then importing, then making my data again, putting those into dictionaries and the labels, fitting it again with TF device, and everything's the same for this one as well. And you can see this trained well. It took a lot longer to train. This was definitely the slowest one, but it did predict pretty good in the end. It very, very slow though. Here the custom config here as well. Again, you could play with around different things for Deberta. TF Deberta for sequence classification from pre-trained Microsoft Deberta base, custom config file. Again, there's a couple different options where you can put the number of labels. It's important that you do that, but you have a few options of where you would want to do that, depending on how much you're using the custom config file. Okay, so learning rate scheduler, compile again with the logits, sparse, and then atom, and then doing the same thing, and then train here. And really, what I'm going to do is I'm going to train only the last layer here. Okay, so just the classifier. Deberta, going through all of these ones, and then doing the same thing, and then TF device, GPU. Okay. And here the predictions. This one I found it didn't really work this best, and truthfully, I found when we trained more of the Deberta, it worked quite a bit better. Okay, so going to RoFormer, same thing for this one. There's really nothing different with the RoFormer custom config file. Training it again, just the classification, and then the one thing when I was importing the tokenizer, I needed to install this rejba library. Just I had to install it. I didn't even have to import it, so I just had to install it to get this to work properly. And just because I don't know if it had anything to do with the Chinese base case that you was one of the models that were available for the tokenizer. Going through this, making the dictionary right here, and then training it again with device GPU. The same thing, and it trained well, pretty good. And we'll go over this a little bit more detail right when we get to the end. Okay, and then doing BERT again, which you might have heard of. So BERT, training this as well. Just setting the labels right inside the for sequence classification, exponential, and then sparse categorical cross entropy. Training again here, only the final classifier layer on this. Okay, tokenizer, nothing really special to do with this one specifically. It was pretty similar to the standard workflow, but let's go down and let's look at the comparisons here. So when you see the test scores, what we can see is training all. We can see that BERT did the best when we retrained everything. So I did this twice, and I just wrote down the numbers manually to keep track of this. So I trained it once with only doing the heads, the classification part, or training all of the model, right? And just to see which worked better, right? So you can see BERT worked best when we're training it all, and with the head, BERT as well. And then the Electra did really, really good. It was always second place as well. But now the time to train, really, which one is the best one in terms of the time? So time per epochs, time to train in total. And this is what really impressed me, right? Because really, even when you think using training only or training all of the classifier, the Electra was just so much faster. What's interesting here is the time to predict for the TFXLNet was quite slow, truthfully, and then the Deberta was really slow on when we were doing it all. So it's, the TXL and Deberta were not really the fastest ones I found. In lots of cases, the TXL is definitely, or XLNet was really by far the slowest one. But Electra and BERT were really good models to use with Hugging Faces for simple sequence classification. Okay, so thank you so much for joining me, and I'll see you for the next Hugging Faces tips video.